question falls under 1.11, which is defining continuity at a point. So we are talking about let f is a function defined by this piecewise functions, and we need to figure out for what value of x that f is not continuous. So if I'm talking about continuity at a point, if any function has to be continuous at a particular point x equals to a, then my left hand limit as x approaches a of a function must be equals to my right hand limit, and also that must be equals to the value of a function at that particular point. So whenever this satisfies, so we say a function is continuous at x equals to a. So the first one, so I'll be checking out whether the function is continuous or not at x equals to 0. So if I talk about at x equals to 0, my left hand limit, so which is nothing but limit x tends to 0 minus. So that means from my left hand side. So when x is less than 0, so sine x is my function. So in that case, limit x tends to 0 minus, which is nothing but sine x. And when we substitute the limit, we can directly substitute it. It is not in an indeterminate form or something. So sine of 0 is going to be 0 itself. My left hand limit is 0. And if I talk about the right hand limit, so which is nothing but limit x tends to 0 plus. So that means for the right hand side, so after 0, so and we need to use this x square statement. This is what is when x is greater than or equals to 0, so x square. And here clearly when you put 0, when you replace 0 in place of x, so we will get 0 square, which is 0 itself. Again, it has nothing to do with an indeterminate form. And also if I talk about value of a function at that particular point, so that means basically f of 0. So f of 0, for that one we need to use this x square thing, because this is what is when x is 0, I'll be using this x square statement. So in that case, basically f of x is x square when x is 0. So that's why f of 0 is 0 square, replacing x with 0, so which is 0. So here clearly my left hand limit, right hand limit, and the value at that particular function is also 0. So that's why x equals to 0, it is continuous. And since the question is talking about not continuous, I can eliminate option A, and I can also eliminate option E, and I can also eliminate option D. So now we are just left with option B or C. Now, if I talk about the second point, so second point is when x is 1, I want to check whether it is continuous or not. So again, let us find the left hand limit. So limit x tends to 1 minus. My left hand limit in this case is when x is less than 1. So that's basically this x square. The function would be x square. And when you replace x with 1, so the reason why I'm directly substituting it in all these sums, so these sums has nothing to do with the indeterminate form. So that's why we are directly substituting it. And when you replace x with 1, so it would be just 1 square, which is 1. And if I talk about the right hand limit, so when x approaches 1 plus, so which means when x is greater than 1, so we have to use this statement, which is nothing but 2 minus x. And in this case also, if you replace x with 1, so this is going to be 1 itself. And value of a function at 1, so which is nothing but f of 1. So value at a function 1 would be, we need to use this equation, which is nothing but 2 minus x. So in that case, it's going to be 2 minus 1, which is 1. So here also my left hand limit, right hand limit, and the value of a function at that particular point is same. That means I can also say this given function is also continuous at x equals to 1. The question is talking about which one is not continuous. So it cannot be x equals to 1 also. So that means answer must be C, but I will also show you why it is C. So for part C, in order to figure out whether it's continuous or not at x equals to 2, my left hand limit, the left hand limit is 2 minus x. That is the function we need to use it, because that is what when x is less than 2. And in that case, when you replace x with 2, so it would be 0. So 2 minus 2 is 0. And then if I talk about the right hand limit, for the right hand limit, so we will be using this x minus 3, which is nothing but x minus 3. And when you replace x with 2, so I'll be getting negative 1. And definitely these two are not the same, so it cannot be continuous. And even if I talk about the value at that particular point, which is nothing but f of 2, I need to use this last function itself, which is x minus 3. So that is going to be 2 minus 3, replacing x with 2, so it's going to be minus 1. So even though my right hand limit is equals to the value of a function at that particular point, but all these three are not the same. So that is the reason at when x is 2, there exists a discontinuous. So that means a function is not continuous only at x equals to 2 for this piecewise function. So that is the right answer for this sum.